Okay. Okay. So welcome to today's this series of programming lecture. And before the lecture begin, I have something we need to introduce first. We need to get straight first. First is this course is designed as internal training for Cortec. So the main target audience is actually those members of Cortec. But even within Cortec, people have a vastly different level of programming experience. Some major in CS, some just learn programming when they got to Mobago. So this course is designed to get some fundamental concept correct. So it will help you learn a existing programming language or learn a new programming language, or help you use current programming language better. So this is the general setting about the class. And so the first is one, do not become good programmer after the lecture, because programming is not something you learn by like having a lecture. It's something that you learn by countless hours of overworking and debugging. And the second is one, do not become expert in any sort of programming discipline. By this I mean if you want to become good programmer as a data scientist, or good programmer as like web developer, or a good programmer as like system architect, this course will teach you none of those, but it will teach you the basics of programming. And one, do not become master of theories underlying programming, because there is a vast theory underlying programming, algebra, category theory, and how do you design programming language, type, compiler, and all that. So we don't talk about too much about systematic theory, but I think it should be okay here, because last time I checked, none of you are interested in programming language theory, so it should be okay. And a brief note about programming language. So here I want to talk about the subject, programming language a bit. So programming language is a science about language. So it concerns all those similar things that you would learn if you are like if you major in like foreign language, history, or literature, or all that. It concerns about how a language is designed, and how do we properly understand a language, namely and also like the history of language, the history of the evolution of language. So all those classical study about language actually applies here, but programming language is a bit different in the sense that it's a subject specific for engineering. So we don't have so much philosophy, we don't have so much history, but we have more. What we have more is objective. Each programming language is designed for a objective which matters, and it is from these objectives that we design and learn and improve programming language. So yeah, programming language as a subject, we need to be very practical, always thinking about the kind of problem we try to solve, or the kind of ideas that we try to express. So that being said, it means there is no such thing as like wonderful or perfect programming language, because it's always under certain context and to achieve certain purpose. Yeah, but still everyone have their preference, and mine is of course Scala, and yeah, that's the best in my own opinion. Okay. And today we'll be talking about these following 8 topics. First is a reason for the subject. motivation for the subject. And we'll talk about language evaluation criteria. We talk about influence on language design, language category, design trade-off, implementation method, and programming environment, and future course outline to introduce a bit. So today will be a very general topic. This is a post I saw in React.js.tw community. Somebody asked when he write this thing, C is not declared. Why is the program still run correctly? And if you know JavaScript, this is simply defining a function. So of course you don't have to specify about C. For those people who know programming language, you would think this is a very stupid question, very simple question. But if you really think about it, why do you know this is reasonable? You actually have the concept of name, of binding, of declaration, and definition. You actually know the difference between things being defined and things being evaluated. And these are the underlying concepts that we need to keep in mind when we learn a new programming language, to avoid like us getting confused even on a simple example code. So this is just to give some motivation. Another success case is Spark, because Spark is something that's well known in machine learning data science community. Spark was first developed on Scala, and the programming language Scala was created because there is none of the language in the world handles the so-called heterogeneous parallelism very well, and the author wanted to implement a language that deals with parallelism very well in a programming language level, so that engineer doesn't have to worry about that much. And it is the creation of Scala language that comes first, and then the author of Spark decide to implement everything on top of Scala because it suits naturally with the purpose. So sometimes programming language drive innovation. And I think Decanter AI is also a good example of how the knowledge of programming language could help, because when we first had a Decanter, we used Python, and it was because the time to market and the open source library is abundant, and time to market is important. But then we encountered some issues concerning about efficiency. We were training 3 days for one model, and that was not fast enough for our client. So instead of searching for another library, we just changed the programming language from Python to Scala, and that just speed up the speed by 10 to 50 times. And because the natural multi-threaded support in Scala, it speeded up even more. So Decanter also benefit from the knowledge of programming language. So if we list out the reason for the subject, the first one is it increases your ability to express ideas. By this, think of an example that if you have written any application in web, like Chloe or KK, like there are some web developers here. If you have written web development and then you switch to other language, like maybe just writing Python for data scientists, you already have the concept of data source should be separate from presentation. You have that concept. Not because you have learned the concept in Python or in another language, because that's the natural way that web development will do things. So this paradigm shift will help you express your idea even in another programming language. And second, it improves your background for choosing appropriate language. And for this one, if you're not a team manager or like team lead, you probably don't get to choose programming language, but still it would benefit because you are faced with the choice of choosing a library a lot of time, and sometimes you need to design library for other people to use. So learning programming language help you appreciate the good attributes in a language, and help you choose the right one or design the right one for other people. And it also increase ability to learn new language. The example would be the JavaScript example. If you have the concept of a function of lambda, of name, of binding, of variable, then even if you just saw JavaScript for the first time, you know what that piece of code is about. And it gives you better understanding of the significance of implementation, because how a programming language is designed, if you know it, you will know how to implement your code to make things faster. For example, if you know C, C++, you know their memory ordering. When you are doing matrix computation, you would know, should we do row major computation or a column major computation? And when you know Scala's design, you know Scala's memory model, you know you don't have to consider all those stuff. And you know if you want to make a program fast, you use other approach. And overall advancement of computing, Dikander AI would be a best example. Accelerate machine learning not by algorithm, but simply by changing a language. And now let's get to the more practical part. The first major topic here would be language evaluation criteria. Oh, because the course is designed for internal training, so if you have any question, you can raise your question anytime. It should be a discussion, free discussion anytime. For language evaluation criteria, there are four major criteria. One is the readability. It's how easy you can read a program, and the writability, how easy you can write it, of course, and the reliability. This one I will explain more, and then finally would be the cost. So one of the examples when we talk about readability is the overall simplicity of the language. Okay. The first example I give here is how does the programming language give you a shorthand of increment a variable by 1? And Scala has none. If you want to increment a variable by 1, you just write it this way. And Python has none. But interestingly, if you write this ++ x, it actually works in Python. And the ++ x in Python means it actually means the interpreter read it as positive x, then positive x. So it's just x. It's actually not incrementing it. So Python also didn't provide a shorthand for it. But if you look at JavaScript has x plus x, and x plus equal 1. JavaScript provide three ways of doing it, and whether this is good really depends. One of the things is, for example, x and ++ x have different return value. That is more implicit, and people who are not familiar with the programming language might not be aware of that. So that becomes a gotcha or a caveat for JavaScript. And if you can write things in different ways, it might, in a good way, you can say it provides flexibility for a programmer. But then you would doubt that, why do you need this kind of flexibility? Does it just cause confusion because different people would write things in different style? So in the programming language design, simplicity is important. And next example, we talk about for loop. Scala has the syntax of a for x in certain iterable list, and then you can iterate with the for loop. And Python has a very similar syntax for loop. But JavaScript have a newer JavaScript also included the syntax. I forgot when, maybe it's ES5 or something. But the older JavaScript have a C++-like for loop. It's you have a for, and within it there are three statements. One is initializing a variable. Second is a condition of stop, and third is a side effect you do between each iteration. So which one is easier to read? For a programmer who have received education in C, C++, of course they think this one is customary, but that's just because they received the education there. But for a normal person, I would say this is more intuitive, because it almost sounds like a language. I'm iterating through something for every x in this collection, so this would be more intuitive. And but the second concern would be, do they really mean the same thing? Not necessarily, because if you write things this way, there is a sequence is implied in this notation. It implies that you do it first with I equals 0, and then you do it second with I equals 2. A sequence is implied here. So what if each loop has some dependency? For example, in let's say if in each loop here, you are adding something to a global count. If within the loop you are incrementing each one to each global counter, then this becomes problematic, because like imagine we want to make things run parallel. Then we have the issue of lock. We have the issue of race condition. So because this kind of notation implies sequence, so it doesn't guarantee that if you run things in parallel, things won't break. While this kind of notation doesn't tell us anything about sequence. It just says for each element inside iterable, do these things. So don't make any assumption about the order of execution. So these two for loop actually kind of imply different things. And another example would be import. Scala has a pretty consistent import syntax. You can import something. You can import multiple things, or you can import and then rename something as another name. And Python, Python also use import. But if you want to import multiple things, you do from A import BC. And Python also give you a rename syntax, import A as AA. And JavaScript is a huge mess. It has a long history of evolution, and every version is different. So I'm not talking about JavaScript here. But this messy import syntax also causes a problem. And it could happen that in a project that's not well set up, you have one kind of syntax for your source code, another kind of syntax for your unit test, and then a third syntax for your end-to-end test if you don't set up the project correctly. And then all of these becomes very terrible. Oh, today it will sound like I really hate JavaScript, but that's just because of the examples today. There will be some more topics in the future where I demonstrate the design of JavaScript is actually good in some cases, but not in today's lecture. Okay, another language evaluation criteria is called orthogonality. The word means you have a minimal operations, and you can combine it any way you want, and things would still work. This is called orthogonality. Orthogonality means you have a minimum set of keywords, and you don't really have to worry about special cases or exception. And because this way of saying it is a bit more abstract, so I'll use a C++ as a example. In this table is the kind of data structure supported in C++, and you read it from column to row. So this would be a pointer to pointer. This would be a reference to pointer. This is a array of pointer. And then this would be a pointer to reference, reference to reference, array to reference. And here would be likewise. So for C++, we have the concept of pointer, reference, and array. Each of them are different. Pointer is a variable containing an address. That address reference to another object. Reference is just a reference to another object, which is not the copy of another object. And array is just an array. And in C++, because array is kind of represented by pointer. But if you don't know the meaning, it's all right. But you just, here in C++, pointer to reference, reference to reference, array to reference is illegal, which doesn't make any sense for people who is not a language expert. But they make it this way because there is a challenge in designing compiler to compile things correctly if they allow this. But if you are just a user of the language, you wouldn't know this. So this would be an example of bad orthogonality. And if a language have good orthogonality, usually it results in people write programs in more uniformed way. And actually, Python have very good orthogonality, and Scala also have good orthogonality. So if a language have too little orthogonality, like C++, it means a lot of exceptions to remember. Then if you want to train a person to write the program, you need to teach them a lot of stuff. But too much orthogonality also makes the language very complex, unless the number of primitive is small. By the word primitive, we mean things like pointer, like reference, like array. Like these are the language primitives. Yes. Okay. And onto that's for readability. Then onto writability. Let's take unit test as example. Actually, I think this has to do with both readability and the writability. And when we choose a language or when we train a programmer, it's always important. A concept to keep in mind is don't let your speed of programming hinder your speed of thinking. You should program at a level that should be as fast as you think. Of course, it's not possible because we really think too fast. But we want to try every effort to program as fast as we think. And sometimes it means just buying a faster computer. Sometimes it means using a better editor like Vim, or use a better IDE, set up your hotkeys and shortcuts. But sometimes it also means choosing the right programming language that can express your idea without too much translation. That way it makes the programming language easy to write. And this I give an example of unit test. In Scala, you can write things this way. X should be 1 plus minus 0.1. And I'm guessing all of you who don't know Scala know what this means. It's a test to test if X is within the range of 0.9 to 1.1. And in machine learning, it's quite often we have to do this kind of test because things are not deterministic. Sometimes things are uncertain. And in Python, you can write it in two conditions. I wrote it wrong here. It should be end. Yeah, but in Python you can write two conditions. You can say it's less than this or larger than this. And for people experienced with statistical programming, they know that you are testing for an error margin. But it might not be so obvious for other people to know why you are testing this upper and lower bound. But PyTest also support a utility called approx. It kind of help you do the same thing, but it makes it not that readable. because if you don't know English well, you won't be able to guess what this 1 and 0.1 mean. You have to look into what these two parameters mean, at least. Maybe, or what if I place the order wrong? I place it as 0.1 and 1, then the whole meaning is wrong. And JavaScript provide something similar to this pytest.approx. So it uses the expect x to be close to, and then probably user can guess 1 is the target and 0.1 is margin. Although there is really no rule to guarantee this is the case, but then at least they have some utility to help. And the reason why JavaScript and Python can never write something like this is a language restriction, because they don't provide something called they don't provide like I don't know how to call it. The way Scala do it is you need to be able to do implicit type conversion. So Scala actually the way Scala do it is Scala look at 1, and Scala realize 1 doesn't have this plus equal operator, so it looks at its type conversion hierarchy, and it realized that, oh, there is a user defined type conversion that converts 1 to something like unit test number or something, and then this unit test number has a member method called plus minus, happens to take in the parameter of double, and then it is able to know that this whole thing should be compiled that way. So this is the language support level that enables you to write something simpler like this. And another example would be here. If we want to write a summation of 0 to n, takes in a parameter n and then sums from 1 to n recursively, which is a easy program. And if you are to look at Scala's code, it's actually it actually fits how we would think about recursion. If n is 0, then 0, else n plus sum n minus 1. This would be a very natural. And here I provide a Haskell version, which is even more natural, because Haskell you can define a function twice. So, and it looks exactly like mathematical definition now. It says natural number sum of 0 equals 0, and natural number sum of n equals n plus natural number sum of n minus 0. This is exactly the definition. This doesn't involve any level of programming translation. So yeah, so these would be examples that it represents our ideas directly. So when we write program, we actually don't have to use our brain. We use our brain to design program, but when we write it, we don't really have to think about it, because it translates directly to program. With Python, it's all right, but Python, you need to write a return. And this word return is very confusing for mathematicians. Mathematicians don't understand the concept of return. But this is something from C, C++ programming. Because you know the word return actually because you know a function is executed in a sub-process, and the sub-process return a value. That's where the word return comes from. But if you don't need to know that, then you don't need to write the word return. And JavaScript is kind of like Python, except you also have to write the bracket. And yeah, I do found a hacky way of writing this. Sum n returns n and n plus sum n minus 1, and this is a hacky way of doing things. This is based on the assumption that if n equals 0 in JavaScript, it's treated as false, and then false is also treated as 0. So it's based on a lot of implicit conversion. Yeah, so this is a not very readable piece of code. Okay, and when 30 years ago, wait, yeah, 30 years ago, you would be using punch card, and this would be an excellent example in very bad writability and very bad readability. So, so we actually have come a very long way. So here is just a list of writability criteria. So same as readability, we want simplicity and orthogonality. And something I didn't give example is we want support for abstraction. This sounds very natural because almost all language now support OOP. But if there are people who write JavaScript before ES5, JavaScript actually had a really bad support of OOP, and it's actually not even what we would call OOP. It used a very strange prototype pointer to point to other class that it might use its method, and that makes the abstraction level really bad. That's why front-end engineer usually cannot write on pure JavaScript. They have to write on more front-end library that does better abstraction for them. And by abstraction, there are many levels. Like class would be a abstraction, or can you abstract? Are you able to abstract? Create a new type, create operator overloading. All those could be abstraction, and different language does have different level support for OOP, for type system, for operator overloading. And then there is this expressivity. It's actually only in the not very long. It's in the recent 20 years that human invented the for expression. And before the for expression, you have to use very hard-coded way to write a loop. But once for expression is invented, then it's very easy for us to express the idea that we want to iterate through a stuff. And now with a functional language, we have map, reduce, fold. We have more and more language that's used by modern concepts. And including all those in a programming language help programmer to express ideas faster and better and more accurate. And then fourth, there is a reliability. It's how do you enable user to write error-free code? And this is a very important thing that I will expand it into more example, because in Mobago, as all of you know, we don't have a lot of people, but we have to maintain an extremely complicated large amount of program. And how are we supposed to do that? Reliability is very important. If you write code in less reliable language, you need a very large team of QA, people reviewing each other's code, a lot of people debugging it. But if you can just write some code and it's correct, it actually helps to reduce the cost of your development resource. So reliability, one of the prominent feature or like evaluation criteria of reliability is how often do you just compile and the thing just work and actually work correctly. These people who write Python and JavaScript rarely have these probably doesn't really understand this, because JavaScript and Python doesn't compile unless you use TypeScript or Python supporting the type decorator. But so usually a JavaScript program is you write it and you really run it, and then see if things are correct, or write unit tests to test it. And I will demonstrate this later about how a compiled language can help with these kind of error. And another thing that would help you to just compile and run is the provability of the language. This is this guy is Knuth. Knuth wrote the classic for it's called the art of computer science, or the art of programming. I forgot, but Knuth is the guy who started the whole subject of theoretical computer science. And this is his famous saying in his textbook. He said, "I have only proved it correct, not tried it." This would, of course, not work in a practical sense. But this is actually very, very helpful as we design distributed system, as we design complicated program. Does the programming language allow us to kind of prove it first before we write it, instead of write it and then tracing out every possibility to see if things are correct? For things that's complicated, provability is important, and we'll get to more of this when we talk about functional programming in the future lecture. So how can a programming language help reliability? One is type checking. If we know the error in compile time rather than runtime, it helps. It forces the designer. First it helps the programmer, because you don't have to really start the whole thing and then try to debug where it went wrong. At compile time, you have the visible error message. And but the second benefit is it forces the designer to think more clearly, because if a language doesn't have a strong type check, you can pretty much write everything and it will pass. It means sometimes you use a variable that has that as a type integer. Sometimes you use a variable as a type class, and it's okay, because the programming language kind of encourage you to write things this way. You don't have to think beforehand about, if I have this variable A, what are its responsibilities? What are the rules and its responsibilities? You don't have to think those through. But forcing a type system makes you think more. When you design a function that takes a input parameter x, you already is forced to think about what are the type of x. How can you use the x inside the function, and all that. Yeah. So in R, when I was a statistic programmer writing things in R, a lot of statisticians write functions in a way that takes into a parameter and then verify what type is it is, and then determine by what type is x, then do the things they want to do. Then that kind of code is impossible for other users to know the exact responsibility of the function. Like if I need to add a new function, if I need to add a new type of parameter, should I add a new function, or should I just add a new case inside the existing function? Like all those would be kind of it's not very systematic in the design process. And another would be exception handling. How does the program handles exception? Does it handle exception as some sort of built-in control, as a language feature, or does it support? How much does it support exception handling? Does it support it as in type system or as language construct? All those would affect how well a language can be used. And good readability and writability does also count. It helps you write a more reliable program. And provability, that's what we talked about. Okay. Now this is a example of code that was buggy, and we just fixed it 2 weeks ago. And just by glancing it's actually not that easy to find out where it went wrong. In fact, it's impossible to know where it went wrong if you don't know other parts of the code. But actually, here we misspelled the word. It should be progress message, but we misspelled it as a progress message. And this is actually very hard to debug. It took we were lucky when we just look at the code and we suddenly realized this word is spelled wrong, and then we catch the error. But But why would this kind of error happen? There are actually many reasons. But if we talk about it in the context of type checking, this thing body, it's a JSON structure. A JSON structure doesn't have the concept of type, or very weak concept of type. It has number, it has string, boolean, and that's pretty much it. And if a JSON object, and a JSON object doesn't restrict the kind of key it can have, so you can pretty much just stuff in any kind of key, and as a return return value also can also be any kind of type. So when we work with JSON, we need to be careful about this kind of stuff. So this would be one example of the importance of type. But then what would happen if body is a type? If body is a type, you will have to define what kind of key body has, and what are the exact type of those key value. And then if you use it wrong, a compile time would already tell you an error. It might tell you an error about this is not a member key of body right at compile time, or the progress message when gotten out. If it's used wrongly, compile time will also let you know. Okay. This is another example in Python, and okay. Here, I created I kind of made up the example. So I have a function called self-reveal. Self-reveal will just print whatever thing that's passed in this function. And x equals this map with key being self-reveal and the function being self-reveal. So if we call x bracket self-reveal, we get the function, and we call it with x itself. So it prints x, which is this hash map. And all these seems normal until now. But then we can reassign x to none in some other cell, and then we call this again. It tells us type error because non-type object is not subscriptable. What does this mean? It says because x has been changed to none, and you can't call bracket on a none. That's what Python means. And what does this has to do with type checking? Because in Python, x can be of type dictionary here, but then after some line later, you are free to assign it to other type. And this is not problematic if you're not writing a large program. But in things like when data science is doing their work on Jupyter Notebook, they have 10, 20, 30 cells. They have to make sure they have good programming habits. So one cell doesn't modify a variable that's used by another cell. Because if you modify it, error would be thrown in another cell. And you would be kind of confused about why this happened if the program is not structured correctly. So, yeah. And I will skip this one. Okay. Then for language evaluation criteria, the last one we talked about cost. Cost is something that's practical. If you really company really is considering about switching language, it's never just because engineer like this language, so we switch language. There are many dimensions we need to think about. One is how hard it is to train the programmer to use the language. This is, of course, something important for every company that has a team instead of just a single person. And how hard it is to write programs and maintain program. This has to do with, like in Mobego, if we are doing a product, how hard it is to maintain the product is of very, very important concern. But if you're a company that does a solution, like you make up something really fast and you sell it to your customer and you don't have to maintain it, then maybe the speed to develop it becomes more important. And yeah, compiling program. Some program need compilation, some program doesn't. It affects the way we deploy. It affects the easiness in the development too. So this also would be something to consider. And how do you execute the program? This also is important because you need to think about your client, your service. Is the way you execute your program like okay? Does it support both development and the testing and the deploying? And then language implementation system. Do we have free compilers? Some language doesn't have free compilers, but most language has. But another problem is, does the free compiler acceptable for your business purpose? That's also something to consider. Oracle was trying to, because the best JVM is probably still written and maintained by Oracle, although there is a free version called OpenJVM. And a lot of companies didn't think about that, so they use Oracle JVM to do their business. And then when they become rich and profitable, Oracle start suing this company because they are using their compiler without paying them license fee. So this would also be something to consider. And reliability is also, because poor reliability leads to high cost. As for these are the points that for business concern, and specifically for Mobago's machine learning application. We also want to consider about how well does it support deployment architecture. And it includes its container, its thread model, its memory model, and how portable is its executable. If we want to make a model deployment service, can people just ship the executable to all their terminal device? And does it support the licensing method we want? Because we might be making a lot of money based on the different price plan or locking different feature, then how secure it is to support that. And extensibility. Do we have a large pool of open source library that we can choose to keep up with the market need? So all these would be practical concerns about choosing a programming language. Okay, and now onto a more historical topic. Just to let you have a feeling that actually we have come very far, and programming language will not be as it is always. It will still keep improving, and better programming languages are still coming up. In 1960s, that's when a lot of applications becomes more and more complicated, user applications. So people efficiency becomes more important, and this needs drives the importance of readability and better control structure. So before that, in programming there is something called go-to. It means you can go to certain lines, and breaks means you can just break out of certain the loop you're in, or jump. Jump is similar to go-to. These kind of things are natural when you write your program. Like you write this line, you write next line, and you think if this condition is met, I want to jump back to that line. But this turns out to be a bad way of thinking because it's hard to understand. It makes the program hard to understand. And when the need of a good readable program is more important, then these kind of constructs are disabled. So we start developing other ways of programming language starts supporting other ways to do the similar things. And in 1970s, that's when OOP or say our program, the way we write program shift. The way we think about program shift from process oriented to data oriented, and this is a very important concept. And do we still have process oriented programming? We do, and it's still important. It happens in a scenario where you need scripting, and data science is the best case. In data science, we want to write one line, and you want to see the results, and write another line and see the results. Your program reflects your work process in a sequence. So, but it pretty much only is important here when you have a scripting need. But for applications, we want to model our applications in terms of the data it represents. For example, in our machine learning, how do we model an automated machine learning? How do we model each actually machine learning model? And we hope that program reflect the complicated application structure, instead of people need to trace actually how each line connects to the other line to know about what the program is about. And as a result, in 1980, OOP becomes more and more popular, and concepts like data abstraction, inheritance, polymorphism, all these becomes a hard concept, but important concept that one needs to learn to be a good programmer. And in 1990, functional programming start to come out. Functional programming is a field of programming that has a very strict mathematical discipline. The theory starts from 1960, when Alan Turing's teacher, Church, he developed the theory, and Alan kind of refined it, and a lot of people work on this whole theory. But the theory is just a theory. It started to get popular in 1990. It's because the implementation of programming language keep up with the theory, because functional program can now be run with acceptable efficiency, and also computer hardware become better. So this programming paradigm has always been good, but due to its slow runtime, it doesn't get popular until 1990. And now in 2000, we start have our language is shaped by more and more other need. One is REPL. REPL is the full name is read, evaluate, print, and the whole thing is a loop. This is REPL, and I think the REPL become popular because data science, data mining, big data become popular. People need to quickly visualize their data instead of needing to write a program, compile it, and see the result. And if the result is wrong, then debug. So this REPL interface is the Jupyter Notebook would be example, and R language, in RStudio would be an example. And some compiled language also support REPL, like Scala. Scala is a compiled language, but also support REPL. And web is also shaping the programming language. How do you represent UI component? How do you represent style, layout, and all that? So our language continue to be shaped and changed today. And there are different language categories too. I will separate it into imperative and functional. These are two major language category, and some people would say OOP. I don't think OOP is a language category. I think OOP is a language feature. So if you use functional programming or you use imperative language, they can all support object-oriented programming. But in imperative programming, the central features are variables, assignments, statements, and iteration. You would see all those kind of stuff, which is still represents your process, your work process. It's more process-oriented way of thinking. And functional programming is based on a study called lambda calculus, where variables denotes constant values. There is no assignment and iteration, and it's recursion only. That means you don't have you don't use iteration. In fact, iterations are can be written in the ways of recursion. Okay, so this is very quick going through the topic. Oh, and the following will be 3 examples. This example is called anagram. And an anagram is an anagram is a pretty common LeetCode problem. Let's maybe go through the code a bit to understand. To understand it would be faster. So if we have a whole bunch of words, so let me switch to Scala first. Okay. So anagram is a data structure. The key is alphabet, like a key is a string of alphabet, like let's say apple, and value would be all the legal words that you can get from the rearrangement of these set of alphabets. And this is a bad example. The dog. Oh, okay, yeah, I got one. Okay, so if you have dog, then you have a dog, and you also have God. So an anagram is a dictionary that gives you these key value mapping. Yeah, and this program seek to construct a anagram from a whole bunch of words. So let's look at how JavaScript write it. It first read words. It reads a whole bunch of words, and then it initializes some variable that we don't know the meaning currently. We only know the meaning of these variable as we continue to read the program. So it iterates through all the words, and for each key, it makes sure that the words are sorted. The reason they need to sort it is because they want to guarantee, like dog and or God, after they sort, they become the same key, and the way they guarantee it is by sorting the string. So it gets the key, and it check if this anagram already has key. If it doesn't have key, initialize it with a empty list first, and then for this anagram, we push these new words into this key category, and then we updated the thing called max. This max is because at the end we want to print out the key that contains the most legal words in it. So we keep updating this value max as we adding words into the anagram, and then we iterate through everything in the anagram, and we see whose length is equal to the max, and then we print it. Okay, this is a very rough introduction, but before you try to understand this, I want to talk about many bad things about it. First is locality. When you are reading about these variables, you don't know what they are about. You have to continue read the program and understand the entire logic before you can come back and then understand the meaning of the variable. This is called bad locality. A good locality means you can understand a piece of code just by where you are looking at them. But then these programs demonstrate bad locality, and I mean in the short piece of code it's all right because you are smart, you understand this quickly. But in code like thousands, hundreds of thousands of lines, it becomes very painful to trace. And it's one thing that imperative programming tends to get bad locality, although it's not necessary. There is always abstraction, there is always ways to avoid it. Yeah. And let's look at Python. Let's look at Python. So up to this point, it's all right. You're reading a bunch of words, and for each word, let's see how it's constructing the anagram. It initializes an empty dictionary first, and then for each word, it appends the word to its correct key. It gets the correct key again by sorting. And so this is already much better than before, this whole thing. But how come Python can be simpler? One of the reasons is because it provided easier ways to sort some string, like in Java, like as opposed to JavaScript where they sort it this way. In Python you only have to sort things this way. Or maybe safer ways to doing a dictionary assignment. All these would be like some of the features in language design that would support you to write a simpler program. So after anagram is constructed, then we get the anagram that has the maximal length. So this part of the code is also easy to understand. We take the maximum of the value of the length of ana, which is everything in anagram's value. Still not so hard to trace and written relatively elegantly. And then we are printing out everything. We are iterating through the anagram and print out everything that has the length that's larger than equal to count. Actually, here should be equal because count is already max. So Python is already a bit better to read, better to understand, and better to maintain, easier to write also, because also notice this is this kind of syntax, length ANA for ANA in anagram.values, because JavaScript doesn't support this way of writing things. So everything, if you write things in JavaScript, it has always to be a for loop. But Python supports this way of making the understanding easier. And but there are still issues with language design. Let's look at Scala. For Scala supports something called group by, which I think the newer version of JavaScript also have this kind of thing. And when this is built into the language, because the process of constructing anagram is basically a group by process. If you're a data scientist, you know group by. You group elements by its key. If they have the same key, it's grouped together. And supporting this group by means we don't need the whole part of the code to construct anagram by ourselves. And it also supports its built-in class have more supported member method. For example, like size. Size here is a member attribute of a class, but in Python, if you want to get the length, you use another function. It's written outside. So the here when you see length of ANA, it's not too bad. It's not too bad because it's only one element. But if you look at the max here, there is a whole lot of stuff inside. You have to admit you need to spend some time to first figure out what are the things inside before you know what this max is about. So but if these functions are built in into the code, let's say let's read this piece of code just in sequence. So we have a whole bunch of values, and let's read it until here. Now all these values become size, and then we are taking the maximum of the size. So the way you understand the program is in the exact same sequence as the way the program is written. These kind of enable us to write better program too. Yeah. So this example just give us a brief example about. It gives a brief example about how different language category and design might affect us approaching a simple problem, the same problem. Okay. Wow. Okay. And should we take a break? Maybe 10 minutes. And I don't have much left. Okay, I don't have much left. Let's take a 10 minutes break.
Imperative 跟 function， 我以为都会分 imperative 跟 declarative。
什么
declarative 就是
declarative
宣告式跟表，但 imperative 是一个是 declarative 是宣告式，就是像那个 Haskell 或是或是那个 Scala 那样，它就是宣告型的，然后它不会先开始做，它就是把东西先 define 好，然后喂资料进去。然后另外一种是 imperative， 就是做一步做一步，说一步做一步，就像 JavaScript 那一种。
我觉得单纯只是我没有学过那个 declarative 这个字。
另外一个 imperative 的
其实应该是严格来说分成 imperative 跟你说的这种 declarative， 对，还有分 logical。但我觉得 logical 现在大家不会遇到了。
Logical 是像前面的那个 process oriented 那一种，
没有都没有 prologue，
这样
prologue 就是 logical 的，但是现在不太有人在写这种东西。
prologue
我觉得它快消失了，就是 logical 是另外一种。
可是logical 算是在做电子电路那一块吗？还是它是算软体开发？
没有，它其实会拿来做 AI 研究。哦，对，
好酷，
没错。但是好像没有什么人在用现在。哇，
你准备好多哦。
今天是真的很盖路。
蛮好奇你现在人生懂多少？
其实我也有点好奇。
我觉得可以做5小时，因为我自己是因为都有写，这3种都有写过，所以我觉得我可以感受出你准备的东西。哦，对。但我很好奇，底下你只写过其中一种的话，会怎么 feel？ 对，因为那个 feeling 是什么？
主要还是做部门内训，但是，
那你们部门的人都有来吗？
我们部门的人有来，
我看很多 DST 2、
3。
部门内训不是必带吗？等下，部门内训不是必带？
其实也不是，
靠腰。
大家程度都不一样啊。
对
对啊，像今天应该对你来说应该不太有什么新的知识吧？
会啊，我觉得像是那个 onto， 像我会念 ontology 嘛，是这样念吗
Ontology，
就是那个
对
你讲说
orthogonality，
对，那个我就不是很知道它是，就我以前就没有学过这个东西。
哦，
可是，所以我理解上那个东西算是，因为你讲说，如果太多 orthogonality 的话，除非你有
language 本身不能太复杂。
对，所以 orthogonality 它具体的意思是指它的
它在 programming language 这个领域没有严格定义啦。哦，但是因为通常在数学里面 orthogonality 的意思就是说。是不是东西怎么组合，可能最后都是一样是 legal 的这种感觉，
就完备性，
完备性
算是完备性，就是等于说有些语言它完备性太弱，所以就一堆例外，像 JavaScript 这种，干，妈的一堆 bug，
对，
就是它没有办法组一组，最后都成一样的东西，像乐高就很有完备性。
对，我觉得一种是完备性，另外一种是你是不是真的用最少的可能去 construct 还是你加了一堆？
如果用最少可能去 construct 的话，代表它是有很高的 orthogonality 吗？还是算它是很低的？
最少可能，而且大家的组合都是
对。所以越高的 orthogonality 代表说它可以用最少的组合去做到一样的东西。
越高
是这样讲吗？还是倒过来？因为其实我不太那个词的意思是越大代表越怎么样？
越大哦，
我怕我讲倒过来。
越大应该是代表
越 orthogonal 的话，代表是它越
好。越 orthogonal 的话，代表说你直觉上觉得合法的操作真的就合法。
哦，
对。
所以算是以 JavaScript 就是算不 orthogonal， 然后可能 Python 跟 C# 比较 orthogonal 一点。
对，
就觉得合法就是。
Python 作者在设计 Python 的时候，他有说就是他希望这个程式语言设计出来之后，大家解一样的问题的写法是差不多。
我觉得他很努力的往这个方向，就是尽量的往一样的思路方式去表达。因为其实我也觉得程式语言这种东西不应该是一个，就像你说的，你写的速度应该要跟想的速度差不多。
对，
应该换句话讲，我觉得比较好的说法是你想到解法，你应该就会写了。
对，没错。
它不是一个限制你写东西的东西。
这个太重要了。
其实写到后期就会发现，其实重点真的是你想不想得到。
对，重点是想不想到，
想不到都没辙。
对。
所以像这个我就没有学过。其他的，我觉得 JS 的部分有一些可能小误解啊。
好，希望可以跟我解释一下吗？
因为我先讲一下，这位就是目前在钻研 functional JS 的部分，他现在是 JS 小达人，我现在要跟他讨教。没有，
你说我有讲错都直接出来，最后没有关系。
他现在在认真看 functional programming in JavaScript 这一块，然后就是有国外很多大们，就是反正有一个叫 Front End Master， 然后他之前有去读那个。
没有，这是一个 Front End 的教学的。
对，就国外的一些人。
有，不过其实我去嘴 JS 的这些东西，都是因为我刚开始学 JS 的时候其实是 ES5才刚出来，很多 browser 都还没有支援，
就是早期的开发
完全理解。
所以其实 JavaScript 确实是试着在改善这些缺点。
对，就是他有，
以前
大家要提出各自的 solution。
prototype 那个真的是bullshit，感觉 prototype
我真的没办法想象，就是
跟那真的很干。
就是以前的人是怎么用 JavaScript 写 OOP？
以前的面试才还好不好？以前面试都在问
考prototype， 还有那个什么
apply 跟 code，
对
apply 跟 code 差在哪里？然后后面的那个参数不太一样，有后面参数是很多个，还是一个，它是 list， 干不一样。然后还有各种历史来历史去的，你也不确定那个历史是哪个历史。这我觉得真的很嗨。
下一堂课我会讲到这些东西，因为下一堂课讲那个 name 跟 scoping。然后如果你是写传统 JavaScript， 你就要对这个概念很清楚。
对啊，因为那个 var 就会让你的 scope 大乱啊。
那个 var 真的是会雷爆的。不过现在像 ES6之后就根本没有，我觉得它改善蛮多的。以前的那些奇妙的东西它都改掉了。但有些是改不了嘛，像怒我这种，像是怒那个什么
Type of Null
Type of Null 是 object，这个是改不掉的。
这有时候写太久没有回来检查 Type of Null 的时候，干又写
就是
一个 Type of
像
Null，
Type of Null 是 object，这个真的改不了，
这个真的不行。
因为他们有一个更高的 principle 叫做 Don't break the web， 这是在 Web 世界里的 principle， 所以
对，所以这个其实他们的
还改干，全世界的网站都停了。对啊，所以他们自己作者也说不能改。
对，这个就是
我前阵子就是有写到
特色，
就是我要写一个检测器啊，就是后端要给我Null的时候，我要改那个
你就
资料型别，
你就exactly等于Null就好了，干嘛用 Type of Null？
没有，因为其他的型别都很习惯就用 Type of， 然后 Type of Null，
那你原本 Type of Null
就爆了
啊
？Null 就等于Null就好了，对吧？
那也就是
还好它Null等于Null是true。
靠不了，那都不是数，那就不用玩了。
对。
有2件方法可以做，第一个是比较简单的方式，是把留在正确的去强迫把这个答案第二个方法就是不要用
没有，就是人家检测器。
这样子就直接告诉他不要这样子就算是
所以你们这个内线的 purpose 是因为你们的 team 有很多会用到跨语言，或者是要更了解语言本质的求职吗？
哦，对，就是因为我觉得很多不是，就是可能不是本科系的，或者是说就是真的不见得就是对口语这么有这种敏感度的人，他们很多时候会卡住的地方是在这种比较 basic 的理解的层面这样子。
哦，
对对对，
就是程式语的本质，还有底层一些。
对啊，其实真的要说可能还有很多，比如像 network 有基本基础知识嘛，然后对啊，只是我目前觉得 programming language 好像是比较fundamental的。
你怎么会想要讲这个题目？
我刚才
就是他刚才问的。
我就听完之后想要问一下，我就觉得真的很奇妙啊。就是内训讲这个，我不知道对他们的帮助的差别，因为毕竟首先就是干 language 就像你一开始说的，如果你不是 tech lead 或什么，你 language 已经被决定了，所以我好奇是说这个题目对他们的帮助性的。
因为其实就是 training 上遇到很大的瓶颈，都是会发现是因为卡在这些观念不了解。
但如果没有算是针对，所以你没有，因为后面也有针对方向在说，是吗？
就是后面
对特定领域
有真的，可是其实就那边就真的更深了，我那边就只会稍微提，那边就真的是当做一种 free sharing。对，其实我最希望讲清楚的是那个naming、scoping、type，我觉得这3个概念是。
我觉得要有这个意识会需要
来讲那个 JS，
就是有时候太久没有写。
我们昨天才在认真研究说，我问你哦，像你们像在 Scala 里面的开 conversion 嘛，你数字1加字串1跟字串1加数字1出来的 type 会一样吗？
首先那个字串1加数字1加字串1是 illegal 的，是 illegal，
是 illegal 的，你看吧。
所以这
样不对，2个都是 illegal 的。
它就是没有隐式转型。
有吧？有另外一边没有隐式转型吗？数字1，因为任何的 variable 应该都有类似 to string 的这种。
没有 Scala 没有这样。应该很多都有，但是你说直接去加吗？加可能有，
不然它怎么 print？ 它一定有 serialization， 对，它应该。没有，我用加好，不好意思，我讲加好，就是
加
字串1加数字1，应该是合法的。
对，加可能。
对，然后但是呢，在 JS 里面干两边，我就在跟他讨论这件事情。我说干那个，反正那个 conversion 很没有逻辑。
很屌，我知道，JavaScript 这边很屌，非常屌。
就是有时候
超级屌，
他在转型的时候，
就是很莫名。
你想的跟他实际呈现起
对。
JavaScript 这世界真的太神奇了。好，那我们先继续哦。
好。
So I want to explain something first because today's we go through some of the major topics, and all of them we go through them pretty fast. And if you really cannot follow up, I think I hope at least you can understand that there are these aspects to consider, and they actually matter, not just because of our theoretical interest, like 我们不是时间太多，就是 they actually matter. That's why we discuss these problem in a business setting. Okay, so another large category is about programming language is has to do with its implementation method. By this I mean the programming language, how the language is implemented, and one major type is a compiled language. A compiled language usually goes through a lexical analyzer first, and syntax analyzer, intermediate code generator, optimize it, and code generator. So what compilation mean is actually I want to define it very easily in a very simple way. If you translate a language to another language, it's called compilation. That's all. It doesn't restrict to any language, and in JavaScript world, they like to have another term called transpile, because you have a newer version of JavaScript syntax, so you transpile it to the older version. But I think in the compiler sense, I would also consider that as compilation, because it's basically translation of one language to another language. And why do we need this? Because imagine like in our company we have usually our computer is Intel CPU, and the thing that runs on Intel CPU is assembly language. This is very hard to write, and this language is specifically optimized for your CPU architecture. If you were to write a program here, it takes very long. And remember in the programming development history part that it becomes more and more important for people to write program easily. So higher order abstraction, functional programming, parallelism, all that become important attribute to a programming language. But so we have a higher level programming language. Compiler is something that try to gap the distance between our high level language to the assembly language. So when you compile a program, it actually analyze the meaning of your program and try to make it work in the assembly language so that it can runs on the CPU. So this is compilation, and here I would to briefly introduce what are the purpose of each. Let's look at these example. Lexical analyzer is something that help you distinguish if a certain unit in your programming is correct. Take Python as an example. This example, if 1 is larger than 2, print life is a maze, print love is a riddle. If the Python interpreter see the program, it will realize there is an invalid indentation here, because Python programming language requires exactly the same indentation for the same scope of code. So this would be something that can be found in lexical analyzer. And so lexical analyzer is kind of like it defines the correct basic units of your programming language. So if I speak in English, there is a lot of legal English words, but like a few months ago, we were teaching Jonathan about some Chinese, like 胸口碎大石, and that's not something that's a legal lexical in English, so that would just fail the lexical analyzer. And for syntax analyzer analyzes if your syntax is correct. And programming language like to code syntax, but I think it's very similar to when we say grammar. Like you can say a whole bunch of words, each of them is correct, but when you connect them together, it's a word that doesn't make sense because your grammar is wrong. So program also have syntax analyzer. In this example, we have z equals 2, y equals 2z plus 2. This is actually a syntax error because although this is the right syntax in terms of a mathematical language, but in Python you cannot write 2z. You have to write 2 and times z. That would be the right syntax for multiplication. If you write 2z, it's wrong syntax. But when compiler breaks down everything, y is a legal syntax. Y is a legal lexical. Assignment is legal. 2 is legal. Z plus 2. They are both independently legal lexical, but it's the wrong syntax. And finally, we have a semantic analyzer. And I couldn't have this in Python because I don't really know if Python have any semantic constraint. But semantic is the meaning. Semantic check for the correctness of your programming language, of its meaning. And if a programming language doesn't have the concept of type, usually it's very hard to check for semantic. And here we have an example. We assign a variable as 3.3. This is legal, syntactically also correct. And we define a function f of x, taking in x as a type int and returns the type int. This is also legal, grammarly also correct. But when we call f of x, this becomes a type error because f is meant to take a integer, but you are giving it something that's not an integer, so the meaning is wrong. So this level would be a semantic error. And the nice thing about a compiled language is it catches all these kind of error for you at compile time. So you don't have to like only wait until you run the program and get some like null pointer exception or like none does not a method of something. Okay. And another way of implementing a language is much easier. It's called interpretive. An interpretive language example would be R, Python, JavaScript, HTML. You put the source program in interpreter and inputs, and then it just render you the results. So it's pretty simple. Yeah, doesn't have so many stages optimizing it translate to another language, then you have to run the compiled code to get the result. Interpretive language is just taking in your source code and then give you the results. And it usually has a benefit of its platform independence, because remember in compiled program, we compile the program to the language on a certain architecture. So if you change a different architecture, you might have to compile it again for that platform. But interpretive language is because as long as you install the interpreter on that machine, you can run the program on that machine. So it's a system platform independent. And but it usually is slow. It interprets a statement each time it is executed. And compiler doesn't have because interpreter doesn't have a global picture. It cannot predict what you will type in the future. So if multiple statements can be optimized together, interpreter cannot know. So interpreter is usually slower. And now there is also a hybrid language. A hybrid language like we have a interpreter, but we still have a certain level of compilation. We still perform certain level of checking, compiling to make sure the code is optimized and efficient. But we don't. But we have an interpreter that makes sure we can just run the program without too much work. Yes, and I wanted to quick introduce Scala, but I'm skipping it here because these might be too much information. Oh, and the REPL, we explained the concept too. It's something that allow you to just read, evaluate, print. I wouldn't say it's a implementation, but I would say it's a way to allow you to develop a language. And for modern language, it's important that it support REPL. So if you know the concept, something that's beneficial is the reason why we need REPL is because we need to quickly debug something that's along the process. Like data science, we want to quickly check if after the transformation, the data frame looks like what we want. And one similar case happened when we were writing end-to-end test. End-to-end test is a automated front-end test. It simulates how an actual user will click on your website, and it's very hard to write. So and also kind of hard to debug in the traditional way, because you have to like click all the way from the beginning to that point to know that where it went from. But REPL support to end-to-end test allow us to just stop at a certain place and type certain command to see if we are selecting the right button, clicking on the right button without triggering out other stuff. It allows us to develop the program faster. And one remark I want to say is theoretically, all language can be implemented in all kinds of ways. Meaning you can implement Scala as interpretive. You can implement Python as compilation language. It just depends on your purpose. And if the demand is high, people will do it. That's theoretically there is really no coupling between language and the kind of method that it can be implemented. But usually there is a most popular one, and that's still important to consider. Yeah. Okay. Oh. Hey. And so today's we finally over on a brief introduction about language. Now we have 8 class remaining. If I persevere and you also persevere, the first three class. These first 3 classes these are the 3 that I care the most about, and I do think it will benefit a junior programmer as you try to become a better programmer. One is the concept of variable name. Binding is how the concept of binding will help you think about the difference of seeing a variable and its actual value, and type checking and scope. All these will help you read and understand the program. And data type itself can be a topic, because it's important to think about type. The right type hierarchy will help you write a good program. And then expression and assignment. In programming, sometimes we do things. Those are what we cared about. Sometimes we calculate things, and the calculated values are the things we cared about. And these need to be distinguished. And I will update the topics in the future, because I will not be talking about language category. And so there are 7 topics left. And these 4 will be much harder topic. Subprogram. How do you design a subprogram? How do you think about it? You can just say it's a function. Every programming language has a way to let you define function, but usually they treat it very differently, and different implementation and design of function give you different capability of writing program, give you a different expressivity. And OOP is a large topic, but for OOP functional programming and parallel programming, I will only select a few practical examples and talk about them. I won't be talking about any theories underlying them. Okay. Oh, and so this is for those who are interested in learning more about programming language. These are homework, and homework is a lot, so you won't be able to finish them. I provide them just if you are interested. You can see what you want to learn more, and you can just do the things you are interested in. And the first is knowledge, because what we learn should not be separate from like what we do every day. So after you know these concepts, you can look at your current programming language and try to figure out if it's compiled or is it interpreted or other. How does it differ from a normal compiled language implementation or a normal interpretive language interpretation? Is your language compiled and support REPL at the same time? How is it possible? How does it do so? Is it strongly typed or weakly typed, statically typed or dynamically typed? I haven't talked about these terms yet, but I will be talking about these terms in the lecture about type. But you can kind of look these words up and see what they mean for a language. The thing is, one way to learn a programming language is just start looking at some tutorial, write some example code. There is nothing wrong with that. It's just it takes some time to accumulate experience and avoid making mistakes. Another way of learning a language is first understand its category, like the words here. Is it strongly typed or weakly typed? What kind of parameter passing method does it use? On what data structure? Understanding all these categories already makes you like know the language like 90%, and then the rest are like the examples. Yeah, and for OOP, does it support multiple inheritance, mixing interface abstract class trait? How is a function implemented and represented in this programming language? This help you think about its efficiency. Like MATLAB. MATLAB is a famous statistical programming language. It supported the idea of lambda function, starting from which version I forgot, but it was when I was studying master. But the way it's implementing lambda function is very bad. So when you write things in lambda in machine learning code, it gives you really bad performance. And it has to do with how they represent function in this language. And can the language return a function? How does it do so? Does the function call support by call reference, by call value? Can we override operators for the language? Knowing all this would already give you a really, really good picture about what this language can achieve and what stage does the language can bring this company to. Yes, and okay, so those are just knowledge. And for hands-on, I suggest a problem. It's called sieve of Eratosthenes. Jonathan, do you know how to read this? Okay. It's an algorithm to find primes, and it's actually it does so by sequentially eliminating prime in its multiples. For example, if we want to find all primes less than 10, we start from 2 and eliminate every multiple of 2. So we get we originally have 2, 3, 4, 5, 6, 7, 8, 9, 10. But eliminating all the multiple of 2, we get 3, 5, 7, 9. And then we eliminate all the multiple of 3, we get 3, 5, 7. And then we do it for 5, for 7. And then we know that we get all the prime number before 10. This is a very good example because you can write it with a for loop. You can write it with imperatively. You can write it functionally with recursion. You can even write it with some really cool data structure. I do provide all the solution here. Python solution can be found here. Scala solution can be found here. and you can write it in shell. So if you are very new to programming, I encourage you to write the same problem in shell, in Python, and in Scala, to just have a feel about how different language approaching the same problem, how might they be different, and how elegant each of them can be. And there is this course about Scala. I highly recommend you guys to take. It's not just to learn Scala. It has a good basic fundamental programming concept. And this is a book written by MIT. This book has been around for so many years. And by the time they write the book, it's called a scheme programming language. Scheme programming language is really cool. You would write a language with a whole bunch of brackets. Yes. And but the language is the readability and is extremely bad, but the language is very well designed in terms of its scope, typing, and all those language support. And this course talks about the design of language with the example of a scheme programming language. This is how it's spelled, scheme. Yes. Oh, I will post the slide on all the slides on SlideShare, and I will share the link to the Gitter channel. And the last would be reading. I share the class again. I must really like the class. This is the class I talked about, and this here. If you are serious about becoming programming language expert, I encourage you to try to learn a language in a more formal way, instead of just looking at a bunch of tutorials and examples. Although if you are a very beginner, I recommend you start from examples. I think that's more interesting. But if you already have some level of programming and you want to level up, next time you learn a language, I encourage you to read the syntax of the language and get yourself familiar with that kind of language. I provide example for Scala. And for Python, if you're a Python user, I recommend you read chapter 2, 3, 4 of Python document. Talks about their lexical analyzer and their data model and the execution model. It gives you much deeper understanding about the memory. The language. And finally, if you are interested in learning about theory, I also have a whole bunch of things. First is this one is a class based on this MIT book, and this one is a class on category theory, which is a theory concerning the proper typing and the proper provability of a program. And yes, so there's really plenty of material for different purpose. And thank you all for coming here and listening to all these. I'm not sure how useful it will be for you, but I hope there are some keywords that's useful for you to continue. And in the future lecture, I hope when things are more focused, it would be more applicable. Okay. I think that's it.